In 2017, something passed through our solar system that should not have been there. It wasn't a planet, it wasn't a comet, and it wasn't bound to the sun like every other object we've ever observed. It came from somewhere else. For millions, maybe billions of years, it drifted silently through interstellar space. Then, without warning, it cut through our solar system at extreme speed, curved around the sun, and vanished back into the darkness between the stars. By the time astronomers realized what they were looking at, it was already leaving. And the more scientists studied the data, the stranger the story became. Because this visitor didn't behave like a normal object in space. It accelerated, without a visible cause. To understand why that was shocking, you have to think about how the solar system normally works. Everything here, every planet, asteroid, and comet, is trapped by the sun's gravity. The sun acts like an invisible anchor holding the entire system together. Earth orbits it. Jupiter orbits it. Even distant comets follow long, looping paths around it. Escaping the sun is extremely difficult. Near Earth, an object must reach roughly 42 kilometers per second to break free from the sun's gravitational pull. Almost nothing naturally reaches that speed. But the object discovered in 2017 was moving at nearly double that. It wasn't orbiting the sun, it was just passing through. That meant one thing. This object did not originate in our solar system at all. It came from another star. Astronomers named the object Oumuamua, a Hawaiian word meaning the first messenger from afar. It was the first confirmed interstellar object ever detected. At first, scientists assumed it was a comet. That would make sense. Comets often travel on elongated paths through the solar system. But there was a problem. Comets have a clear signature. When they approach the sun, the heat vaporizes ice on their surface. Gas and dust erupt outward, forming a glowing cloud called a coma, along with a long tail stretching through space. Oumuamua had none of that. No tail, no visible gas, no dust, nothing. So maybe it wasn't a comet, maybe it was an asteroid. Except asteroids don't accelerate when leaving the sun, and Oumuamua did exactly that. The mystery deepened when astronomers tried to determine the object's shape, because Oumuamua was far too small and distant for telescopes to capture a clear image. Instead, scientists studied how its brightness changed as it spun through space. The pattern was dramatic. Every 7 hours, the light reflecting from the object surged and faded repeatedly. Bright, dim, bright again. That meant Oumuamua was not round. It was extremely elongated. Imagine a cosmic object spinning end over end like a tossed baton, or possibly something flat and thin, like a cosmic pancake. Either shape would explain the strange flashes of reflected sunlight. But that only raised another question. What kind of natural object forms in such an unusual shape? The real puzzle, however, was not its shape. It was its motion. As Oumuamua moved away from the sun, astronomers noticed a subtle but measurable increase in its speed. That should not happen. According to gravity alone, objects leaving the solar system should slow down, not accelerate. Something was pushing it. But there was no visible jet of gas, no plume, and no sign of outgassing like a comet. This unexplained acceleration sparked intense debate among scientists, because there were only a few possibilities. Either we were missing some natural explanation, or the object was something entirely different. Some researchers proposed a simple explanation. Perhaps Oumuamua really was a comet, but one made of unusual materials. Not water ice, something harder to detect. For example, nitrogen ice. Nitrogen gas is invisible. If a fragment of nitrogen ice were heated by the sun, it could release gas without producing a visible comet tail. The escaping gas would act like a tiny thruster, just enough to explain the acceleration. Where could such an object come from? Imagine a distant dwarf planet, similar to Pluto, made largely of frozen nitrogen. If that world were shattered by a massive impact, fragments could be ejected into interstellar space. One of those fragments might wander the galaxy for billions of years, before briefly passing through our solar system. But even as scientists debated the explanation, something unexpected happened. 2 years later, we were visited again. In 2019, astronomers detected another interstellar object. This one was named Borisov, after the amateur astronomer who discovered it. Unlike Oumuamua, Borisov behaved exactly like a comet. It had a visible tail, a glowing coma, and gas streaming into space. Its composition appeared remarkably similar to comets found within our own solar system, which suggested something important. Objects from other star systems may not be so different from the ones here, but the pattern was surprising. For centuries, humanity observed the sky without detecting a single interstellar visitor. Then suddenly, two arrived within just 2 years. That realization changed how scientists think about the galaxy. Our solar system is not isolated. It's moving through the Milky Way at enormous speed. And other stars are moving too. Over millions of years, gravitational interactions can eject asteroids, comets, and planetary fragments into interstellar space. The galaxy may be filled with trillions of wandering objects, tiny messengers from distant solar systems. Most are simply too small and too dark to detect, but occasionally, one passes close enough for us to notice. When that happens, it becomes an extraordinary opportunity, because each interstellar object carries clues about the planetary systems where it formed. In a sense, they are pieces of other star systems drifting through the galaxy. And recently, astronomers discovered yet another one, a third interstellar visitor. This time, scientists detected it before it reached the inner solar system, which means for the first time, we can watch an object from another star system approach the sun in real time. That changes everything. Instead of catching a brief glimpse as it leaves, we can study it for months, measure its composition, track its motion, and possibly learn how common these cosmic wanderers really are. Each new detection brings us closer to answering a larger question. How many fragments of distant worlds are drifting through our galaxy right now? For billions of years, our solar system seemed like a closed neighborhood, planets orbiting a single star in quiet isolation. But Oumuamua changed that. It revealed that the galaxy is not empty space. It's a vast ocean filled with debris from countless other star systems. Fragments of ancient planets, shattered comets, objects older than our sun itself. And every once in a while, one of them passes through our cosmic backyard. The question is no longer whether this happens. The question is, how many of these silent travelers are passing by us right now?